Hello, everybody. Well, I'm sorry I'm not there to teach you this lesson today. Just since I started this lesson, I noticed I already have some typos. It says any questions over 1-2, that should really be 2-1. And then I need to cover section 2-3 with you. So, little typos there, but it's not going to change the lesson any. Here's what I have going today. If I was there, I'd answer any questions for you, but I'm not there, of course. I do have a pairs check for you. Here's how we're going to handle the pairs check today. Here in a minute or two, I'm going to ask Miss Jensen or my sub to pause the video. And I'm going to ask them to hand out a pairs check form. What I need you to do is find a friend, find a partner. And then, here's how this is going to work. You're each going to have the odds, or you're each going to have the evens. You and your partner will have the exact same problems. Normally, I make sure one of you have the evens, the other one have the odds. But I want each of you to have the same problems this time. Work together, use your notes, and see what kind of damage you could do on them. So I'm going to ask Miss Jensen or my sub to hit pause the video right now. And we're going to give you 10, 12, maybe even 15 minutes, whatever we need, to get this pairs check done. And then once we're done there, we're going to start the video back up. We're going to hand out our class notes. And then I need to cover slope and rates of change with you. I think it's easier than what it was last class. So at this time, if the sub or Miss Jensen would stop the video, and then we'll give you some time to work on your pairs check. Welcome back. Hopefully the pairs check went pretty well for you. I'll get those this weekend and I'll get those looked over. What I need in front of you right now are your class notes. And I'm going to kind of start medium to easy back to medium. So it kind of sounds a little backwards. But I'm going to kind of start with what I think might be the hardest part for you. So if you will, look at your class notes that look like this. This should be the first example that you see. It says, find the average rate of change for the data in the table. The hardest part on finding the average rate of change is you need to decide what your units should be. Here's what I mean by your units. Notice your time is in hours, and then the elevation of the sun is in degrees. We need to decide if we want to say degrees per hour or hour per degree. We need to decide which one sounds better. Well, if it's warming up throughout the day, it would make more sense to say it's warming up by 5 degrees every hour. It wouldn't make sense to say every hour something. So when we do this, this is our x value, this is our y value. And notice that there's quite a bit of data in the table. What I need you to do is concentrate on the first piece of data and the last piece of data, because they want the overall elevation change. So here's what we got going. We want to figure out how many degrees it's changed compared to the time. So here's what we're going to do. And then we'll give this another name here in a second. From 11 o'clock to 7 o'clock, it went from 6 to 84. So I'm going to go 84 degrees minus 6 degrees. Notice that my top unit so far is degrees. On the bottom here, let's talk about time. I'm looking at 11 o'clock, it was 84 degrees, and then at 7 o'clock, it was at 6 degrees. Hey, now I'm going to simplify that. I'm going to go 84 minus 6 is 78 degrees over 11 minus 7 is 4 hours. And if I simplify that, I get that it's going to change by 19.5 degrees every hour. That's called a rate of change. We're going to see how much this column grows compared to how much this column grows. So here goes your number 1. If you would, put an X above that column and a Y above that column. And if you think about your units, I want to talk about people per minute, because it looks like these are growing by minutes. The auditorium filled up by so many people per minute. So if you would, look at the top and the bottom. You get to ignore the middle, because we're worried about the overall change. What I need to do is figure out how many people that the auditorium grew. So it maximum had 151, and I'm going to take away 26. That's going to tell me how many people that changed in the auditorium. In what time frame did that happen? It happened from 7:40 to 7:15. I could also write this as 26 minus 151 over 7:15 minus 7:40. But I'm going to get in the habit of going the second minus the first. So here's what I got. 151 minus 26. I've got 125 people over 740 minus 715 is 25 minutes. You can grab your calculator and go 125 divided by 25. If you do that, you get 5. But 5 what? It's going to be 5 people per minute. Meaning in this case, on the average, every minute, 5 additional people walked into the auditorium. So here would be my answer. On these kind of problems, guys, you got to make sure you have great labels. Look at your number 2 then. If you would, put an X here and a Y there. And then look at your chart to see what kind of data we're working with. This column is the altitude of a balloon in meters. This is the time. So picture this. You have a balloon and you let it go. It's filled with helium or something. So it's rising up into the air. I'm going to ask you, how fast is it rising? So here's what I need to do. Look at this column compared to that column. You get to ignore the middle ones. I want to go meters per minute, so I need meters on top. And I need minutes on bottom. So then here's what I got. I've got 3,320 meters minus 520. That tells me how many meters it raised up, how many meters it rose. Over 23 minus 3. This tells me how many minutes it rose. If you simplify this, 3,320 minus 520, you're going to get 2,800. So I've got 2,800 over 20. If you simplify that, you're going to get 140. But 140 is not the correct answer. It's a piece of the answer. What is it? It's 140 meters per minute. So my balloon was going up 140 meters every minute, which makes a lot of sense. But this is all there is to rates of change. Look at your number 3. I might pick the pace up a little bit. Make sure you understand what you're thinking about here. The second column, which is my Y column, this is my X column. The second column is talking about the vehicles that travel through a tunnel. My first column is talking about the minutes. So it makes sense to say vehicles per minute. So I need the rate of change of the vehicles over the rate of change of the minutes. So we're going to compare those two columns and those two columns. Hopefully you have an idea of what I'm going to do. I need to figure out how my vehicles changed. So I'm going to go 3,432 minus 1,610. That tells me how my vehicles grew. Over 28 minus 4. Hey, I want you to notice this also while I'm here. The 3432 and the 28 go together. The 1610 and the 4 go together. And now, right now, I'm in vehicles per minute. So let me go ahead and simplify this. 2432 minus 1610 is 1822 over 24. If I simplify that, you're going to get a decimal. I'm going to round that to approximately 76. 76 what? Vehicles per minute. Vehicles per minute. So notice, guys, it's this value, this change, over this change. Here goes my number 4. Think about it again. It looks like we're dealing with the depth of a sinking stone in meters due to the time. So you picked up some rock, you threw it into the river. Well, what's that rock doing? It's sinking until it hits the bottom. So if you think about what your unit should be, meters per second. So compare this column and this column. I'm going to pick the pace up a little bit now. I'm going to go 8.73 minus 3.51 over 29 minus 0. If I simplify this, I'm going to get 5.22 over 29. If you run that through your calculator, you're going to get 0.18 what? Meters per second. So I got a couple more of these, and I'm going to switch gears on you just a little bit. I think if I was there, I would say, try number 5 and number 6, and we'll see how you do. Since I'm not there, we'll go ahead and do number 5 and number 6 together. I'm hoping that you're a little bit ahead of me now. So time looks like it's in seconds. Water through a channel is in my Y column. So it looks like my water in a channel is growing as my time is growing. So let's see what we got. I'm going to go 37,014 minus 22,172 over 47 minus 6. If I type that into my brain or my calculator, I'm going to get 14,842 over 41. Go 14,842 divided by 41, you're going to get 362. Now put your units on there. Liters per second. And then coming to my next one. Did I pass my number 6? I did. Let me slide over and get your number 6. Distance between two sleds in meters due to the time. Hey, it looks like the distance between the two sleds is shrinking this time as my time increases. So we'll see what happens. I'm going to go 7.2 minus 37.3, just like we've been doing, over 13 minus 0. Hey, notice that the distance is shrinking this time. So we're going to predict my answer is going to be negative. So I'm going to go 7.2 minus 37.3, and I'm going to get negative 30.1 over 13. If you divide that on your calculator, you're going to get a decimal. So I'm going to go approximately negative 2.3 meters per second. So I tried to get the hardest part of the lesson out of the way first, called rates of change. If you would now, flip over to the other side and let me talk to you about slope. Let me talk to you about slope. Slope is simply, we did it over and over and over on the last few problems that we did. Slope is simply the change in y over the change in x. I have my calculus kids call it delta y over delta x. Delta means change. And I'm going to give you a formula. Slope is right there. Slope is what you get, and we did it 6 times just previously. Slope is the difference of your y values over the difference of your x values. Don't get caught up in the notation. Y sub 2 means your second y value minus your first y value over your second x value minus your first x value. If you're a little confused on the formula, you won't be here pretty quick. Look at your number 1. I would like to find the slope of the line that passes through each pair of points. We're going to express it as a fraction in simplest form. Well, here's what I got. My formula says subtract your y values over subtract your x values. So here's x sub 1, here's y sub 1, here's x sub 2, here's y sub 2. Pretend it was in a column just like we did. If it was in a column, it would look like this: 4, 7, 6, 13. We're going to do the same thing. I'm going to go 13 minus 7, 13 minus 7, 13 minus 7, over 6 minus 4. And then do a lot of this in your head. 13 minus 7 happens to be 6, divided by. 6 minus 4 happens to be 2. The slope of that line is 3. That's all there is to find in slope. I'm going to go my second y value minus my first y value over my second x value minus my first x value. So here's what I got. This one's going to look like slope is going to be 4 minus 4 over 3 minus 6. 4 minus 4 over 3 minus 6. Well, if I do this, 4 minus 4 is 0. 3 minus 6 is negative 3. If I type that in my calculator, I'm going to get a slope of 0. 0 divided by any number is 0. I'm going to pick the pace up a little bit. To find my slope on number 3, the change in y over the change in x, so negative 3 minus 1 over 7 minus 5. Negative 3 minus 1 over 7 minus 5. Well, negative 3 minus 1 is negative 4. 7 minus 5 is 2. So this slope is negative 2. Here's your 4, 5, and 6. Let me click through these now. I need to go my change in y, so I'm going to go 3 minus negative 3 over negative 4 minus 5. Remember, 2 negatives make a positive. So this becomes 6 over negative 4 minus 5 is negative 9. But that's going to reduce. 3 goes into both of those, so my answer, negative 2/3. And you got it. Here's number 5. I'm going to go negative 2 minus 10 over negative 1 minus 5. Negative 2 minus 10 happens to be negative 12. Negative 1 minus 5 happens to be negative 6. My answer is a 2. All done. Here's number 6. Change in y, so 2 minus negative 4 over negative 13 minus negative 1. 2 minus negative 4 over negative 13 minus negative 1. And what do we know about back-to-back negatives? They become a positive. So look what I really have. 2 plus 4 is 6 over negative 13 plus 1 is negative 12. 6 divided by negative 12 becomes negative 1/2. When you're asked to find slope, never ever use a decimal, because we can graph negative 1/2 really, really easy. And if I was there, I'd ask you to try number 7, 8, and 9 on your own, but since I'm not there, we're going to click through them really, really fast. I'm going to go 3 minus negative 2 over 3 minus 7, there to there, there to there. 3 minus negative 2 becomes 5 over negative 4. So we're going to leave it like that. Another way to write it, we could put your negative out front. It's all good and the same. Number 8, I'm going to go 5 minus 9 over 5 minus negative 5. 5 minus 9 happens to be negative 4. 5 minus negative 5 becomes 5 plus 5, which is 10, which happens to be negative 2/5. And my last slope one, before I look at some graphs, negative 8 minus negative 2 over negative 4 minus 4. Negative 8 minus negative 2, that becomes negative 6 over negative 8. Reduce those and get 3/4. So change in y over the change in x. If you would, look at your last couple, or your last little group there. We're still going to find the slope of it. We're just going to find it from a graph. We define slope as the rise over the run. Which we called the change in y over the change in x. So here's what I need to do. I need to figure out how much this graph goes up compared to how much it goes and runs. So if you would, on your number 10, find 2 places that this graph touches nicely. What I mean at an intersection. So there's a nice intersection right there. So put a dot there. Looks like at 4. And then put a dot right here. That looks like a nice one at 5. Watch how easy it is to find this slope. Rise over run. 2 ways. If you look here, how many units are you going down? You're going down 4 units. Now, how many units are we going over? We're going over 5. So my slope is negative 4/5. That's not the only way you could have done it. You could have started at this point right here and did this. You could say, well, Mr. Harris, I'm going to go up 4, but I'm going to have to go to the left 5. Going to the left is negative, so then I'm going to have 4 over negative 5. Same answer. As long as you do a rise over a run. If you will, look at your number 11. Look and see if you can find two nice places that that touches at. Well, it looks like I find a nice place right here. And I'm going to find a nice place right there. Well, let's figure out. It doesn't matter which dot you go from. If I go from this dot, I'm going to have to go up 1, 2, 3, 4. I went up 4, and I'm going to go over 3. So this slope is up 4 over 3. Up 4 over 3. If you would have went the other way, guys, what would have happened? From here, you're going to go down 4 and left 3. So I got -4 over -3, which is also 4/3. That's all there is to finding slope on a graph. I'm going to click through the last ones because I don't know how the understanding's going since I'm not there. But find two nice places on the graph. It looks like I see a good point right there. And I might see another good point right there. Some things that I know before I even start. This graph's going uphill. So I know it's positive. I just got to figure out how positive. So, looks like I need to go up 2 units. And I need to go over 1, 2, 3, 4, 5, 6. So there's my slope, up 2 and over 6. But that will reduce to 1/3. And then you got it. And then my last couple. And then we're going to be done. So hopefully you think this is an easy day. Go find two nice points on your graph. Looks like it crosses nicely right there at the point 2, 1. And it looks like it crosses nicely right there. That's the bad thing with these graphs. Sometimes it's hard to make sure you're in a good place. So now I need to go up 1, 2, 3, 4. I need to go up 4. And I need to go over 3. So I got it. This is going uphill, so I knew it better be positive. Here's my next one. Find two nice points on there. Oh, looks like there's one. Looks like there's one. Find your slope again. So it looks like I'm going to go up 1, 2, 3, 4. So I went up 4. And I'm going to go over 3 again. So it looks like the same answer. Woo! And my last one. Find two nice points again. Oh, maybe right there. And maybe right there. Something I know, when all said and done, this answer is going to be negative. So I'm going to go down 1, 2, 3, 4. And I'm going to go over 1. So this slope is down 4 over 1, which I'm going to call -4. So guys, that's the rate of change and slope. Of course, you got an assignment, and I know you're going to have time to work on it. So jump on the assignment and do a good job, and we will see you next time.